Imagine a supercomputer tirelessly devouring every scrap of information the world creates. Every image, every word, every spoken phrase. This immense hunger, this insatiable need for data, has defined the age of artificial intelligence. For years, the prevailing wisdom was simple: more data equals smarter AI. The bigger the dataset, the more powerful the model. We built digital giants, fed them petabytes, and watched them learn to write, to create, to speak. But this endless feast comes with a hidden cost, a looming challenge that threatens to slow down the entire revolution. What if the path to truly intelligent AI isn't about feeding it more? What if it's about teaching it to think with less? For specific, specialized tasks, the fuel for these giants, high-quality, human-labeled data, is actually incredibly scarce. Think about identifying a specific, rare type of defect in an industrial process, or tracking endangered wildlife in dense jungles from satellite imagery. Experts need to painstakingly mark every instance. This isn't just expensive, it's often impossible to scale. We hit a wall, a bottleneck where progress grinds to a halt not because of a lack of computing power, but a lack of relevant human input. Many assume the only solution is to find, collect, and label even more real-world data. But what if the opposite is true? What if the AI itself could become the solution to its own data problem? This is the core reversal in thinking that's reshaping AI development. Instead of passively consuming data from the real world, what if AI could actively create it? Not random noise, but new, diverse, and contextually rich examples, perfectly tailored for its own training. This isn't just data augmentation, it's a radical shift. It's AI learning to think with less external data by becoming a sophisticated generator of its own internal knowledge. Think of it like a master painter. They don't need to see 1,000 new horses every time they want to sketch one. Once they've studied enough real horses, they understand the underlying principles of anatomy, posture, and movement. From that deep understanding, they can then generate infinite variations, new horses that never existed, but are perfectly convincing. This is what advanced generative models, like diffusion models, are doing for AI. Take a field like remote sensing, where identifying rare objects in satellite imagery, like specific types of infrastructure or disaster damage, is crucial but suffers from extreme data scarcity. Cutting-edge research is exploring how these AI systems can learn from a limited set of real images, then generate countless new synthetic ones. These aren't just copies. They're novel scenarios, diverse angles, and varying conditions, all accurately labeled and ready to train an AI model to a much higher level of precision. This ability to think with less data isn't confined to training. It's also fundamentally changing how we access information. Traditionally, searching for answers meant wading through a sea of documents, links, and articles. We, the humans, had to do the heavy lifting of synthesis. But now, generative AI is moving beyond simple retrieval. It's becoming an information generator. Instead of just finding existing answers, it can combine, condense, and create new, tailored content that directly addresses a user's specific need. This means less data for us to sift through, less cognitive load to arrive at understanding. The AI synthesizes the information up front, delivering highly personalized insights, a significant leap from just pointing us towards vast archives. This paradigm shift, while promising immense efficiency, isn't without its complexities. The incentives are clear. Generating synthetic data dramatically reduces the colossal cost and time involved in manual labeling. It democratizes AI development, making it accessible to organizations without a budget for petabytes of curated data. But there are crucial trade-offs. If the original, limited dataset contains biases, generating more data from it can amplify those biases, making them harder to detect and correct. And when AI synthesizes information, it also introduces a new challenge for human critical thinking. When an answer is perfectly presented and concisely summarized, it can feel authoritative, even if it's based on flawed generation or subtle hallucinations. The burden of verification shifts, demanding a more sophisticated kind of digital literacy from us. As AI learns to become its own data generator and information synthesizer, our relationship with knowledge itself begins to transform. No longer are we merely seekers of raw information. We become curators and critical evaluators of AI-generated insights. This new dynamic offers incredible potential: faster scientific discovery, more personalized education, highly targeted medical diagnoses. But it also means confronting a world where the lines between real and synthesized information blur. Understanding the origins of the data, the methods of synthesis, and the potential for error becomes paramount. This shift doesn't diminish human intelligence. It redefines its role, demanding a deeper engagement with the nature of truth in an AI-driven ecosystem. The story of AI is no longer solely about building bigger machines and feeding them endless piles of data. It's evolving into a narrative of efficiency, ingenuity, and self-sufficiency. By learning to generate its own training data and synthesize complex information, AI is indeed shrinking the giant. It's becoming powerful and versatile not through sheer scale, but through a profound understanding of underlying patterns, allowing it to create what it needs and distill what matters. This new chapter promises to make AI more accessible, more sustainable, and ultimately, more deeply integrated into the fabric of our lives. The question is no longer just how much data AI can process, but how intelligently it can learn to operate with less, and what that means for how we, as humans, will learn to think alongside it.